Welcome to NM's Arena. In this video, we are going to study how to solve simultaneous linear equations in two variables. Now, the simultaneous linear equations in two unknowns can be solved either using the elimination method or by the substitution method. Both of these methods can be explained here using examples. First of all, let us consider how to solve a simultaneous linear equation problem using elimination method. Now let us consider a question. Here the question is to solve 7 by x plus 3 by y is equal to 11 by 5. And the second equation is 5 by y minus 15 by x is equal to 1. So we cannot solve these equations as such because the unknown values are given in the denominators. So we have to convert it into the numerator. Let us see how it is done. Let 1 by x is equal to a and 1 by y is equal to b. So instead of 7 by x, we can write it as 7a. And instead of 3 by y, we can write it as 3b. Now we can solve the problem very easily. So 7a plus 3b is equal to 11 divided by 5. And this 5 can be taken to this side and multiplied with both these values. So that will be 7a into 5 is 35a and 3b into 5 is 15b is equal to 11. This divided by 5 is taken to the left hand side and multiplied with this. That is how we get 35a plus 15b is equal to 11. So that is our first equation. Now the second equation, this 5 divided by y becomes 5b and 15 divided by x becomes 15a is equal to 1. Now this 15a has to be taken this side and 5b into this side to make the equation similar to the first one. So that will be minus 15a plus 5b is equal to 1. And so for adding or subtracting with the first equation, we have to make both of these same. Let us consider this one. In order to make this same as 15b, we have to multiply 5 with 3. So the whole equation is multiplied with 3. And then we get minus 45a plus 15b is equal to 3. 1 into 3 is 3. So that is our second equation. Now taking these two equations, we have to either add or subtract. Now since both of these are having positive signs, it is plus 15b and plus 15b. So we have to put a minus sign or we have to subtract the second equation from the first equation. Now we get 80a, that is 35a minus 45a is 80a. Minus becomes plus. So 35a plus 45a is 80a. And this 15b minus 15b is 0. That is eliminated. Then 11 minus 3 becomes 8. So 80a is equal to 8. So a is equal to 8 divided by 80. Hence it is 1 divided by 10. So a is 1 by 10. Now we have to find the value of b by applying or substituting the value of a in any of these equations. Let us take the equation 35a plus 15b is equal to 11. The a value is put here. 35 into 1 by 10 plus 15b is equal to 11. And then 35 into 1 by 10 is 35 by 10. And this 11 is taken to this side, minus 11 is equal to, and when this plus 15b is taken to the other side, it becomes minus 15b. And then we cannot subtract this as such. So we have to make this denominator also as 10. So we have to multiply the numerator and the denominator with 10, and hence that becomes 35 minus 110 divided by 10 is equal to minus 15b. The 35 minus 110 is minus 75. So minus 75 divided by 10 is equal to minus 15b. Then b is equal to 75 by 10 into 15. Both sides there are negative signs, so we can eliminate it. Both these signs can be ignored. So that becomes 75 by 10 into 15 is equal to b. So b is equal to 1 by 2. Now we got the value of b. Then a is 1 by 10 and b is 1 by 2. Both a and b are known now. Now we can convert this into x and y. We know that a is equal to 1 by x or x is equal to 1 by a. So x will be equal to 10. When a is 1 by 10, 1 by a will be 10. Then x is equal to 10. Similarly, y is equal to 1 by b or b is equal to 1 by y. So when b is 1 by 2, 1 by b will be 2. So y is equal to 2. Thus the answers are, or the solution to this equation are, x is equal to 10 and y is equal to 2. And now let us consider a different question. Here the question is to find the equilibrium price and the quantity exchanged at the equilibrium price if supply and demand functions are given by S is equal to 20 plus 3p and D is equal to 160 minus 2p, where P is the price charged. Now we know that at equilibrium supply equals demand. For equilibrium, S is equal to D and S is given as 20 plus 3p and D is also given 160 minus 2p. When S is equal to D, then this must be equal to this. 20 plus 3p is equal to 160 minus 2p. This 2p can be taken to the left hand side to be added with 3p, and this 20 can be taken to the right hand side to be subtracted from 160. Then we get 5p is equal to 140. Thus the price can be obtained as 140 divided by 5, that is 28. So the equilibrium price is 28. Now we have to find the equilibrium quantity or the quantity exchanged at the equilibrium. That can be obtained as quantity exchange is equal to 20 plus 3p. So 20 plus 3 into 28 is equal to 104. Therefore, the quantity exchanged is 104. And now our next question is, a man sells 7 horses and 8 cows at rupees 2040 and 5 horses and 6 cows at rupees 2150. What is the selling price of each? So let the selling price of the horse be X and the selling price of cow be Y. Then it is given 7 horses and 8 cows he sells at rupees 2040. Hence 7x plus 8y is equal to 2940. Similarly, it is given that he sells 5 horses and 6 cows at rupees 2150. So 5x plus 6y is equal to 2150. Now we get two equations. This is our first equation and this one is the second equation. Now, in order to eliminate any of these values, we have to make their coefficients same. Let us consider the x values. So the coefficient of x here is 7, here it is 5. In order to make them same, we have to multiply this 7 with 5 and this 5 with 7. So in order to multiply the 7 with 5, we have to multiply the whole equation with 5. And in order to multiply this 5 with 7, we have to multiply the whole equation with 7. So 7x plus 8y is equal to 2940 into 5, we get 35x plus 40y is equal to 14,700. And 5x plus 6y is equal to 2150 into 7 is 35x plus 42y is equal to 15,050. Now these two values are same. Thus we can do either addition or subtraction. Here we can see that both are positive values. So we have to consider subtraction. First equation minus second equation. Hence we are putting a minus sign. So 35x minus 35x we get 0. 40y minus 42y is minus 2y. And 14,700 minus 15,050 is minus 350. Since both the sides there are negative signs or both the values are negative, we can remove this negative signs and the values will be 2y is equal to 350. So y is equal to 350 divided by 2. Hence it is 175. So the selling price of cow is 175 rupees. Now we have to find the selling price of horse, that is x. In order to find the value of x, we can substitute the value of y in any of these equations. Let us consider the equation 7x plus 8y is equal to 2940. Then 7x plus 8 into 175. The value of y is substituted 175. That is equal to 2940. So 7x is equal to 2940 minus 1400. 8 into 175 is 1400. That is taken to the other side and subtracted from 2940. Thus we get 7x is equal to 1540. So x is equal to 1540 divided by 7, that is 220. Now x is 20. So the selling price of horse is 20. Thus we get the price of horse as 220 and the price of cow as rupees 175. And now let us see the next question. A is 6 times as old as B. 15 years hence, A will be 3 times as old as B. Find the ages of A and B. So it is given that A is 6 times as old as B. If B is X, then A will be 6 times of X. So let us see what is to be done. Let the present age of A be X. So the present age, the current age of A is taken as X and the present age of B is taken as Y. And it is given A is 6 times as old as B. So whatever is the age of B, A's age will be 6 times of that. 6 into the age of B. So X is equal to 6Y. The age of B is Y. So x is equal to 6 times the age of y. X is equal to 6y. Then in the second part of the question it is given 15 years hence A will be 3 times as old as B. Now this is the current situation, the present situation. After 15 years the age of A will be x plus 15. After 15 years A will be x plus 15 and after 15 years B will be y plus 15. And at that time it is given that A will be 3 times as old as B. That means x plus 15 is equal to 3 into y plus 15. The age of A at that time will be equal to 3 times the age of B at that time. So we got another equation. Then x plus 15 is equal to 3 into y plus 15 is 3y plus 45. Now 6y plus 15 is equal to 3y plus 45. That is got by substituting the value of x here. The value of x is 6y. X is equal to 6y. So instead of x we are putting here 6y. This is the substitution method. So 6y plus 15 is equal to 3y plus 45. This problem can be solved either by using the substitution method or the previous method that we have studied, that is the elimination method. We can consider this as an equation by taking this 6y to this side and x minus 6y is equal to 0. That will be the first equation. And the second equation we will get from here. X plus 15 is equal to 3y plus 45. This 15 can be taken to this side and 3y is taken to this side. We will get x minus 3y is equal to 45 minus 15, that will be 30. Thus we get two equations. This is the first equation and this is the second equation, and we can solve as we have done in the previous problem. But here we are going to use the substitution method. We are taking x is equal to 6y and applying that here. And we are going to use this method to solve this question, even though we can use any of the two methods. Then this 3y can be taken to this side and 15 can be taken to this side. That will make 6y minus 3y is equal to 45 minus 15. So 3y is equal to 30. Hence y is equal to 30 divided by 3, that is 10. Now we got the age of y. Now we can substitute this value of y here. X is equal to 6y. Y is 10. So x is equal to 6 into 10, that is 60. So the age of A or the present age of A is 60 and the present age of B is 10. That is the answer to this question. The present ages of A and B are found out here using the substitution method. The same problem may also be solved by taking two equations in two unknowns and using the elimination method by adding or subtracting the two equations as we have done in the previous question. And let us try to solve a similar problem using the elimination method. This question is similar to the previous question. Here it is. 10 years ago, the age of a father was 4 times of his son. 10 years hence, the age of the father will be twice that of his son. What are their present ages? So, let the present age of father be x and the present age of son be y. Now it is given 10 years ago, the age of the father was 4 times of his son. 10 years ago means x minus 10 and y minus 10. Then x minus 10 is equal to 4 times the age of his son. 4 into y minus 10, that is x minus 10 is equal to 4y minus 40. Then this 4y is taken to this side and it becomes x minus 4y is equal to this minus 10 is taken to this side. So minus 40 plus 10, that is x minus 4y is equal to minus 30. That is our first equation. Now the second part is 10 years hence the age of the father will be twice that of his son. 10 years hence means after 10 years. So x plus 10 and y plus 10. That time it becomes twice. So x plus 10 is equal to 2 into y plus 10. That is x plus 10 is equal to 2y plus 20. 2 into 10 is 20. And then take this 2y to this side and 10 to this side. We get x minus 2y is equal to 20 minus 10. Hence the equation is x minus 2y is equal to 10. Now this is our first equation and this is our second equation. We got two equations. We can use the elimination method or even we can use the substitution method also. But here we are going to solve this equation by taking two equations together and use the elimination method. Now taking these two equations together, we get the values of x ready for getting eliminated. Since both are having positive values, we can subtract the second equation from the first equation and put a minus sign. So x minus x is 0, minus 4y minus 2y is same as minus 4y plus 2y. Minus and minus becomes plus. So minus 4y plus 2y is minus 2y is equal to minus 30. Minus 10 is minus 40. Since both sides there are negative signs, we can remove it. So y is equal to 40 divided by 2. Hence y is equal to 20. That is the present age of the son is 20. Now we can find the value of x by taking any of these equations. Here we are taking x minus 2y is equal to 10 because that is more simpler for calculation than this one. Any of these equations can be taken. So x minus 2y is equal to 10. The value of y can be substituted here. X minus 2 into 20 is equal to 10. And then x is equal to 10 plus 40. That is 2 into 20 is 40. That will be minus 40. And this is taken to this side and added with 10. X is equal to 10 plus 40. Hence, x is equal to 50. Therefore, the present age of father is 50 and the present age of son is 20. And now let us consider a different question. Here it is given that a grocer mixes tea at rupees 40 per kilogram with tea at rupees 50 per kilogram to make 30 kilograms to be sold at rupees 45 per kilogram. What are the quantities of each kind in the mixture? Let us try to make the question more clear. It is given that there is tea at rupees 40 per kilogram. That is, this tea bag is at rupees 40 per kilogram. The quantity of this tea bag is unknown. Quantity is not known. There is another tea bag that contains tea at rupees 50 per kilogram. So the tea in this tea bag is sold at rupees 50 per kilogram, and here this tea bag, here it is sold at rupees 40 per kilogram. Now here the quantity is unknown. Similarly here also the quantity in this tea bag is unknown. And what the grocer is doing is he is mixing these two tea bags. The two tea bags are mixed to make another tea bag containing tea to be sold at rupees 45 per kilogram. So he is mixing the tea bag of rupees 40 per kg and the other one is tea at rupees 50 per kg, and he is making a tea bag of rupees 50 per kg. Here the quantity is given. The quantity here is 30 kilogram. That is, he make 30 kilograms to be sold at rupees 45 per kilogram. That means the total quantity of tea in this bag and this bag must be 30. Because when he mixes these two bags, he get 30 kilograms. And he decided to sell it at rupees 45 per kilogram. Now we can try to make equations out of this. Here the quantity of the first tea bag is unknown. That may be x. And the second tea bag is also unknown. So plus the second tea bag y. He is mixing the two tea bags and he gets 30 kilograms. So this quantity we don't know. This quantity we do not know. But when we add these two, we get 30. Now that is an equation. X plus y is equal to 30. Similarly, on the basis of this also we can form another equation. 40 into x. So the value of this tea bag will be rupees 40 per kilogram into the quantity is x. So 40 into x, that is 40x plus 50 into y. So 50y. 40x plus 50y is equal to, here it is 45 and the quantity is not 30. So that will be 45 into 30. Now we get two equations. This is the first equation and this is the second equation. Hope the question is clear now. Based on these two equations, we can try to solve this problem. And now we can try to solve the problem. So let the quantity of tea at rupees 40 per kilogram be x and the quantity of tea at rupees 50 per kilogram be y. So x plus y is equal to 30 and the second part of the equation was 40x plus 50y is equal to 1350. This is the first equation and this is our second equation. Now we can use either the elimination method or the substitution method. Let us try to use the substitution method here. So x is equal to 30 minus y. So in order to substitute this in any of this equation, we can find the value of x as 30 minus y. So that we can substitute the value of x as 30 minus y. Now here this x value is substituted. 40 into 30 minus y plus 50y is equal to 1350. So that is 40 into 30 is 1200. 40 into minus y is minus 40y plus 50y is equal to 1350. And this 1200 can be taken to this side. So 10y, that is minus 40y plus 50y is 10y is equal to 1350 minus 1200. 10y is equal to 150. So y is equal to 150 divided by 10. Hence the value of y is 15. Now we can apply in any of these equations to find the value of x. Since this is the simplest equation, let us take that equation. X plus y is equal to 30. X plus 15 is equal to 30. So x is equal to 30 minus 15. That is 15. So the quantity of tea at rupees 40 per kg is 15. And the quantity of tea at rupees 50 per kg is also 15. That is why when we added these two kilograms, we get 30 kilograms in the third bag. That is how we solve such a question. So we have studied both the elimination method and the substitution method to solve simultaneous linear equations in two unknowns. Thank you for watching this video. For more videos, subscribe the channel.